All right, so let's take a look at this Colab. And what's going on, this is ML122. Colab, there are a whole bunch of large language models you can just run directly here, although, as we just found out, at least one of them doesn't work anymore. This GPT-4 Alpaca won't run. It gives some kind of error message, which is, as you've seen in my other projects, the problem is people keep changing Python libraries. So unless you actually package whatever you're doing in a container with the exact versions of everything, pretty soon it will stop working because the people that update libraries don't keep them consistent. So, however, we just tried it and found that this first model here, Vicuna, works. So these are packaged models that are all ready to go. If you just open this page and then scroll down, these Colab links will run it directly in Colab so you can use it. Now, I already done that for the first Vicuna model here, and it's running here. And you will notice, if I can get up to the top, okay, so here's the code, and see, it runs everything, and now it's running this Python server. It's just going to end continuously running this because it's running a web server. So it downloads the requirements and the rest of this model. And by the way, notice the 4-bit quantization. This is a big deal. This is a lot of how you run models on weak hardware. You don't use floating point numbers. You quantize them down to a few bits, and a lot of them are quantized down to 4 bits. So there's really only 16 levels of the weights everywhere. It turns out you can quantize them very far. In fact, there was a paper recently that said you can quantize them down to 1 bit, or just 3 choices, 0, 1, and -1 at each weight, and they still work very well. And that would save a ton of power and use a lot less memory and everything else. So this is a 13 billion parameter model, I think. Yeah, quantized down to 4 bits. And so it runs in this default virtual machine here, which is not terribly powerful. And when you run it, it'll download all kinds of stuff, and then it'll give you a bunch of screaming red error messages. But in this case, you can just ignore them. In the Stanford Alpaca, it gave about twice as many of these, and it wouldn't run. So I don't know why it's, I don't know what that means, but it seems to be okay. After that, it continues to run. And the point is, when it's done, it runs this thing called gradio. gradio is some kind of free web service to host things. So it's going to redirect traffic from this URL to this running Google Python environment. So if I open this link, it's going to give me a ChatGPT-4-like web page I can use to talk to my own model. So this is pretty cool. Like I say, everybody is forbidden at every corporation I know of to use the public models like Gemini and GPT-4 because they train on the data you send up there, and it's not safe to send your confidential company data up there. So you want to run models on your own hardware or on virtual machines you've rented from Amazon that are under your control and not accessible to the whole world and such. So you can now ask questions. And in here, I said, why is the sky blue? That's my standard question to start out with a large language model to see in the bare bones whether it's working. So you enter that and then generate an answer. And we'll see. And you see it's pretty slow. It's running in a container on Google server with, I think, 16 gigs of RAM. And I'm not quite sure. And I think no GPU. Now, you could go into the settings and try adding a GPU if you let you have it. But anyway, there it is giving some kind of answer. So it's moving and giving a kind of correct answer. Then here's one that had often failed before. Does the letter E appear in the word ketchup? And I say I can clear the history. Might as well do that because this is going to take forever. Clear history. Confirm. Okay, now I'm back to this. Now I can see this is one of the many questions it couldn't answer. Let's try this. This one got yes. That's interesting. Yeah. So this answer was in fact accurate. Okay. I got bad answers sometimes too. In fact, if I just ask it the same question again, I might get a different answer. Wonder wonder what happens if I try to do another before the previous one is over. It won't. Okay, anyway, all right. Anyway, and then you got some flags defined here, so you'll be able to see these pretty easily. Stable vicuna, this is the one we just used. Compare the answers to the other, but ketchup answer is especially interesting. So this is the one we're using anyway.
No, Sam, it's not. It's different.
Oh, it's different? Okay.
Yes. Yes. Yes.
13B. Okay, that's what I'm confused about. Okay, what I did before was use the first one. And let's see. Stable vicuna. Oh, it wasn't stable. Oh, so it's this one. Okay, does it work too? Have you tried it?
I'm working right now, actually. So far, so good.
Okay,
Yep.
good. Well, anyway, all right. So it's pretty good. There are a couple minor bugs in this project, but you can do it. And there's a much better way to test these models, much better way to run them on your own hardware. We're going to get to that later. So I'm going to stop this recording.